Hi devs, welcome back to Behind the Code. I'm John Davenport. This is where we take a deep dive into the code of the game that I created for the iOS App Store. The game is called Zeroed, and that's an arcade game. It's a very casual game, and I'll play it right now just to give you an idea of what the game is about, so that when we're looking at the code, you'll have an idea of what to look for. And then we'll dive into Xcode, and I'll show you what I've done to create this game. All right, so here we are in Zeroed. I'm just going to tap play, and we're going to get started really quickly here. For today's video, we're focusing on this thing that keeps reappearing in the middle. So every time I tap on this, it regenerates the resource. Now, as you can see, it's not really doing anything yet because I need to tap on the targets, which are on the left and the right. So you can see when I tap on them once, they turn red, which indicates that the resource value will be subtracted from the target. If I tap twice, it turns green, and the value of the resource is added to that target. Then the object of the game is to use the resource value to bring your target values to 0. When you do that, you score points. If you have a 7 or a 5, so think like 7, 17, 27, or 5, 15, 25. So you either get bonus points for the 5s or penalties for the 7s. When you have a 7 or a 5 on the board, aren't able, so I can't tap this 2 until I clear the 5. Same thing with a 7. If a 7's on the board, you can't tap on the 7 until, or any other number until the 7 is cleared. So that's the gist of the game, and as I said, the object is to make zeros, and once you make enough zeros, you score enough points, and then you win the game. So it's a pretty simple, casual, arcade-style gameplay. So let's jump into Xcode now, and I'll show you all about the code that runs the resource. Okay, so here we are in Xcode, and we're going to start with the resource subclass. Now, this is a subclass of SpriteNode, and it's like I said, it's the center element of the game. So when you saw me playing, it's that centerpiece that we tap to perform the action for the player. And the first thing we need to do is make sure that that element is able to be clicked. So we have it, basically we have a delegate here so that it can click on a resource. And that's basically just a very quick way of allowing me to be able to tap on this and interact with it as a clickable sprite node. And then we set a few other parameters here for initialization. One of the things that you may have noticed when I was playing is that when the resource spawns into the game, it has a bit of an animation. It kind of grows and then shrinks. So that's done with this spawn animation code here. You can see it's basically just a sequence of a bunch of different SK actions. So it has a scale effect to scale it about 30% bigger than its actual size, and then it scales down to its regular size. And that happens in a total of 0.5 seconds. So you can see the initial growing is about 0.4 seconds, and then 0.1 seconds to scale back down. And then we also have a 0.1 second wait that happens as well. So you can see here that the total action is the spawning action, a grow action, then it finishes the grow, which is basically just these two things here where it grows and then shrinks, and then it waits for for that 0.1 second. We then spawn the label, which is the label is the value of the resource, and then we're going to remove the burst animation, and then we run the spawned action, which is just the final action here. And that's basically, so you can see our spawning and spawned. That's that these are actually really important because we want to make sure that as the resource is spawning in, you can't tap it. You have to wait until it's fully spawned, and that just prevents you from kind of misclicking before you even see the label and whatnot. So then we just initialize it. We run that spawn animation with the values that we pass through to it, and the resource is now in the game. And there's a few other things here. We have a timer for various resources, and we create the resource value. You can see the way we do that is we pass an integer in, which is the maximum value, and then as long as that integer is greater than 0, so if it's 1 or higher, we will create a random number between 1 and that maximum value and then assign that to the resource. If it is lower than 1, which can happen if you create 4 zeros at the same time with the 4 targets, because then it takes the value of the targets as this maximum value. So if all of those targets are 0, then it would potentially have a value of 0, which we don't want the resource to be spawning with that. So in that case, the resource will spawn between 1 and 20. And that's really just kind of an edge case that I had to come up with to solve that problem. So really quickly, I'll dive through the 4 different types of resources in the game. So this is like the generic container class. And then we have 4 subclasses of resources. There's the timed resource, power-up resource, mutating resource, and bonus resource. They're very similar across each of them. They're really just, you can see here, they're all just subclasses of resource. So they take all of the different components of the resource itself. But you can see the power-up resource has a variable of power-ups, which let it determine which power-up to give the user or the player when they acquire that power-up. And it also has a timer attached to it, so we have to assign that there. Same thing here with the timed resource. It takes a timer bar. And again, that's really the only thing that's different between all of these. We pass a different texture in when we're creating them, but inside the actual class itself, there's not a whole lot going on here. It's really just for these particular special resources, they all are timed, so they have this timer value to them. So now let's take a quick look at the game scene, which is where all of this logic kind of happens. The best place to start would be in the resource click function. And this is what happens when you tap that middle resource button. So if you remember from the gameplay, whenever that resource is tapped, the math is calculated, animations happen, points are added up, and fuel is given and taken away. And basically everything happens on that click. So it's a pretty important function in the game. And you can see the first thing that we do is we want to give the player some haptic feedback to let them know that they've tapped a resource. And so what we do is we create one of the UI impact feedback generators, which is built into Xcode. And it just creates that simple light tap whenever it's created. So we just put it on and let it occur. Here you can see the next thing we do is we're counting 5s and 7s. This is entirely just so that we can complete a achievement that is in the game, and we need to track that. Basically, there's an achievement. It's a hidden achievement, so if you're watching this, you have a little bit of a secret. But if you create 4 5s or 4 7s, then you will unlock those achievements. And that's how we count to make sure that we have reached that. Then we're taking the resource value that's passed in, which is the one we just tapped, and we set that to the current resource value, which is what we're going to use throughout the rest of this calculation. We're going to pass this value around. The first if statement here is if the resource charges, which is our fuel level, if it has dropped to 0 or lower, then we need to determine whether or not we have the reserve fuel power up active. If we do, that's what happens here. So if the reserve fuel is active or is acquired, if that equals true, then what we're going to do is we're going to set resource charges equals to half of our maximum charges. Now, max charges scales as the game progresses. So as you score more points, you're allowed to hold more charges. So that's why it's not just a constant number. It actually changes over time. And we just divide that by 2 to give half your value back. So we're not giving you a full fuel tank, it's a half a fuel tank. If you do not have that activated, then what we do is come into basically we start a game over sequence. The first thing we want to do is in the stats menu of the game, I'm tracking how you die. So you can die one of 2 ways. The first way, which is what we're doing now, is if you have empty fuel. So we increment that by 1, and then we set it to the user defaults so that it can be stored and then accessed later. And then we run our game over animation. We create a basically like an explosion effect at the source of the game over. So if it's a target that creates the game over, the game over effect will come from that target. In this case, it's because you ran out of fuel, so the game over effect is coming from the fuel tank position. So then if we do have enough fuel, we need to kind of check a few variables here first. We need to make sure that it's not a bonus resource or a power-up resource, because in those cases, if you use them before their timer expires, then you either get a bonus or you get a power-up. The other 2 resources that have timers, the power-up resource and the timed resource, are triggered when the timer runs out. So it's not so important to check if it's those here. If it's either a timed resource or a mutating resource, it just performs the same way as a default resource in this case. But if we are a bonus resource, then we need to calculate the score. We have a point scaler, and then we trigger the fuel charge plus label animation function, which is how we animate the fuel charges. And a lot of these functions we'll go through in more detail in further videos. So make sure you're subscribed if you're enjoying this so far. Now, what we want to do is, because you get more fuel when you tap a bonus resource, we need to make sure that you don't get too much fuel, because we don't want you to keep accumulating fuel above what you can hold. So if your resource charges do go above your maximum allowable charges, then we just set resource charges equal to this number here. Now, if it's a power-up resource, it's pretty simple here. We're just going to pass through that resource and we're going to acquire a power-up from it. There's a power-up that's attached to it. We saw that in the power-up subclass, and that gets kind of translated in this function here, which I'll show you again in a future video. So now we come down to kind of the bulk of this function, and that's what happens when we click on this. Like, how does it know how to subtract everything from the targets and so on? So what we do is we set empty array for the number of selected targets. So we need to track this because with the timed resource, and you can see this down here, with the timed resource, if you just tapped it to use it before the time expired, there'd be no drawback to it, right? You don't have to select any targets. You could just tap through it and then get to the next target or the next resource. But I want there to be a penalty for using it without thinking about the targets that are on the board. So if you don't have, if the number of selected targets equals 0, then what we do is, if that resource is a timed resource, we will do a penalty. Basically, we call this fuel charge minus label animation, and we have a penalty charges scalar, which is it just scales with difficulty. So as you have more difficulty, if you're on a higher difficulty level, or as your points increase, this number goes up. So the game gets harder as you score more points. That's part of how this game works. And that's how we kind of calculate, how we do that. So what you're going to do is you're going to trigger this function every time you are using a timed resource without selecting any target. Now, if you have a target 1 or 4, anywhere between that number, 1 to 4 targets selected, then this doesn't ever trigger. But if you do, then you're charged the penalty regardless, basically as if you just let it expire. So then back to the switch statement here, which is just determining the current state of the target. So we're doing this for every target in the game, right? So at the beginning of the game, we put the 4 targets into an array called level targets. And then for every target in that array, we're gonna switch or check essentially the current state of the target. So case 1 is that the target's off, and right now I'm just printing that it's off. We're not doing anything. There's nothing to be done to a target that's off. Case 2, the target is set to subtraction. So that's if you tap twice, right? If you tap, or if you tap once, the target will turn red and it'll be set to subtraction. So the first thing we need to do remember, this is when we're clicking on the resource. So we need to reset the target state. We don't want it to be set to subtraction anymore. So we reset that. We're going to append this target to number of selected targets so that we know that we have at least 1 selected target. If the user is playing on the insane difficulty, we're going to take 2 fuel from the player. Otherwise, we just take 1. And then we run the function subtraction emitter, which passes the current resource and the target to that function to do some more, basically more calculations and whatnot. And then if the target is a 7 or a 5, we're going to apply that penalty or bonus. So it goes through and it really figures that out there. Now, in addition, if you tap twice and you have your target set to green, we do the addition, which is basically everything that we just said, just in reverse. So, and the only thing really that's different is that we're using the addition emitter instead of the subtraction emitter. And then down here, this is where we do the achievement calculation or determination. Basically, we come in here and for all of the targets, we determine if there's a remainder of a 7, which means that it has a 7. And if there is, we count it as a 7. And then if we have 4 of them and you haven't already completed it, then we report that to Game Center as the achievement for 7s. We do the same thing here for 5s. So if you divide by 5 and you have a remainder of 0, if you divide by 2 and have a remainder of 1, that means it's divisible by 5 and odd. So that means it's a 5. Then we count the 5s. And then as long as you have 4 5s and you haven't already completed that achievement, we award the achievement. All right, so I think that's pretty much it. Obviously, we create a new resource. So let's take a look at how the resource is created. All right, so 2 functions really handle the resource creation. We have create new resource and return resource. Create new resource is pretty straightforward. We get the position of the current resource, and then we destroy that resource. And then what we're doing is we're creating a new resource in that position. And to create a resource, we use the return resource function and we return a resource to this resource, and we set that as new resource, and then we give it the delegate that we talked about earlier. We give it a position and a physics body, and then we add it to the scene. In return resource, as I said, we're returning a resource. We check to make sure that a power-up hasn't recently been created. We don't want power-ups to be very common. We want them to be somewhat rare. So it's first a fairly rare occurrence anyway, and then we make sure that it can't be repeated. You can't get a power-up within the next 4 times you're offered a resource. So it makes it a little bit more rare by doing that. And then what we do is we set we have basically an odds calculator. So this starts off at a high number. So the odds of getting a regular default resource is higher as you start, and then as the game progresses, this odds timed resource becomes lower and lower and lower. So the numbers that are generated by this random number generator become fewer, and the way that we calculate the odds then is based on this set of criteria here. So if that random number equals a 5, then we give you a bonus resource. If it's a 1, 2, or a 3, then it's a timed resource. If it's a 6 or a 7, it's a mutating resource. And if it's a number 4 and our last power-up created equals 0, then we create a power-up resource. And you can see one of the things that we're doing here is we're passing random max value. Random max value is assigned by, first we set it to 0 here. And then we sort our level targets. So we take all of our targets and we sort them from highest to lowest. And then what we do is we set random max value to the highest target on the board. And then we pass that through. The reason that we do it this way and not a simpler way is because all of the targets are always on the board. They're just sometimes they're hidden and sometimes they're not. And so what we have to do is make sure that the level target in 0 first, if it's not hidden. If it is hidden, then we don't come into this function. If it isn't hidden, so if this isn't hidden and random max value, which is 0, is less than that level target value, then we set random max value to the level target value. And that's how we create that random max value. Now, if you remember from earlier in this video, I talked about how the resource value is determined based off the targets that are on the board. So this is that value that we pass in, right? So what we pass in is a string for the image and the random maximum value, and that's how the resource is created. And you can see here, we either create a bonus resource, a timed resource, mutating resource, or power-up resource, or if it's any other number other than the ones that we mentioned, then it's just a default regular old resource. And that's basically it for how the resources are created. I'm going to dive into more detail in future videos, so I hope you are subscribed. If you did like this video, please do take a moment and subscribe to my channel. I very much appreciate that. If you have any questions about the code, or if you have any comments about how I can improve my code, leave a comment below and let me know what you think. I'll see you in the next one.